Hello ladies and gentlemen, I'm going to talk about Pangaea. The reason I'm going to look at Pangaea right here and try to relay what I see to you is because in order for me to better describe which impactors would have impacted first and in what, how that order works out, I kind of have to know how the planet was oriented at the time that it occurred. And the reason that's important is because if the North Pole is here today, then everything from the North Pole spirals down toward the South Pole from that orientation. But if the North Pole was over here, then at the time that it was over here, it would have been spiraling down to the South Pole during that orientation. So being over here, then basically we're just looking at the planet this way, and the North Pole where it is now is like over here or something in this effect, right? So here's the funny thing about it. So as I was mentioning on one of my earlier videos, what I did is I took a world map that was flat. I basically took an objective point of view. I looked straight at the center of it, and then I began to imagine everything coming back into one formation, with the exception of, Antarctica or whatever. So when I did, I pinned the tail on the donkey, so to speak. I stuck my finger right where I envisioned the center of that location to be. And that center put me actually not right here. Right here you see my red dot. That little pin is red so I can see it. But now that's the Pangaean North Pole. That's what Pan NP is for. When I stuck my finger down on the map, it actually ended up somewhere right up in here. So the more I analyzed this area, the more it began to appear to me that this is actually a spiral density fracture. And basically what you have right here is the beginning of the separation that we currently have in the North Pole around the Arctic Circle. So it's not a very clean circular separation, but neither is neither is the Caspian Sea. So when we go back in time, we have to consider, was that particular location where it is right now, is that where the North Pole was then? Or has this entire Eurasian continent migrated from a certain position on the planet to this location, in that up here on the mid-Atlantic ridge and this huge fracture that carries around and comes back over here, we have visible separation where you have Greenland would have pivoted out of this point here, that point comes to this point, Iceland spins and goes right into its little ghosty spot right here, and a lot of this material ended up shifting down, so all of this was up closer. Alaska pivoted in this way, at some point I think it would have had to have pivoted up in here. Chukotka would have pivoted up into here before Alaska pivots up into here. So Alaska is like the closing door. So you have, my left hand is Chukotka and my right hand is Alaska, and if you drew them back up where they were, they would overlap or come into a lap that Alaska is slightly overlapping Chukotka. And then of course Kamchatka would go back up into its little pocket location. Now, the thing that I've been struggling with mostly is, I do believe that's Norway. Let's see, we got the names down there. Do we? No, we don't. Something here, right? I ain't seeing nothing. I don't see all my diggity-doos. Let's turn that, okay, now I turned it off. Now I turned it back on, huh? It just must be taking a heck of a long time to load. Alright, so this is Finland, somebody over here or something else. Well, my computer's slow today. Do-do-do. Do-do-do. Why is it taking so long? This isn't normal. Oh, come on. It's too bad this doesn't have a refresh button. Okay, anyway, this lump of land here doesn't really fit in with any of these, the fracture along the Atlantic here, or any of the other land features necessarily. And its mountainous region here is completely unlike anywhere else around here. So basically what I'm talking about is this particular section of land. I'm going to turn that off because it's taking way too long to load. Don't know why. What I'm talking about right here, ladies and gentlemen, is that this isn't necessarily something that has always been there. So back earliest in Pangaea, when this would have been the Pangaea North Pole, this would not have existed. So, but how can I prove that, and how is it that it would not have existed? And is it true, or is it possible that since Greenland comes from this crack area, basically, and Chukotka comes from very close to it, so at one time it probably was next to it, then it leaves you to assume that this section of this area of this side of the planet with Russia would have been up there as well. So taking that into consideration, the theory could be that since Pangaea was the North Pole, this entire continent had migrated from this fracture down to where it is today. So about this much distance from here to here basically would put Pangaea's North Pole right up in here. But we don't. This is only a thought of, well, is it or is it not? And it turns out that as I'm looking around the planet, I have to say that this was in fact the North Pole for Pangaea, but it did not move. This still is in the formation that it was back when it was Pangaea. And when it was Pangaea, the Caspian Sea went all the way down through here into these two bodies of water. Okay, let me see if I can get this right. Let's see, this one of them is the Persian Gulf, and one of them is the Arabian Sea. So, yeah, well, either way, this was open all the way down into here, okay? And this material here showed up later. Quite a bit later, as a matter of fact. Okay, so like billions of years later. Anyway, well, not billions and billions, because we figure the planet has only been solidified since 4.4 billion years before present. So that means that the planet obviously existed before that. It just was mostly molten or liquid, right? In that instance. Okay, now the kind of curvature that we have with the Caspian Sea is going around like this. Now, if you follow the spiral, basically spiral fracture types of formations, that pretty much gives you the same direction. So it's coming out of here. It doesn't actually begin right here. It's not the body of the water so much as the fracture itself comes around from this point, follows the shoreline, goes around this way here, and then comes around out here. So the fracture is out actually along the body of the water, not the water itself. The water itself does create a depression. So it comes around and it swoops down into here, whatnot. And from this, I went ahead and looked for anything that would appear to be possible lithostream scores. And I found things that appeared to be helpful to make that determination. Now this is where it gets kind of funny. So as I was doing that, I mapped out what turned out to be about 13 what I call Jupiterian stripes. So if that's even legitimately or true at any rate. 13 is 2 more than 11, which is 2 more than 9. So that means that during the time of Pangaea, the Earth would have been rotating much faster. It would have been rotating with about 16-hour days, a little bit over 16 hours. And therefore, when a world-class impactor strikes the planet and agitates the lithosphere then scores the surface of the Earth, and it's that score that makes that record that allows us to see what was the Earth doing at the time that that impactor struck the planet. So this is where I'm getting 4 world-class impactors from. And oh, by the way, I've decided that due to the amount of extensive damage that the South China Sea had caused, I'm going to bump it up to a class that I'm going to refer to as a galactic class. And the reason that is because it not only agitated the lithosphere, it agitated the asthenosphere, is basically how my theory goes. That's where you get the asthenospheric tsunamis. And as far as I can tell, it's the only one that has had a hemispheric effect on these underground tsunamis of molten lava that come up and pop up around the world wherever it happens to be the path of least resistance. So now this would have been the North Pole before the Himalayas ever became the Himalayas, and so on and so forth, and all of this. It would have been not quite as mountainous. Now, these guys actually spilled out, and this spill out came from this little guy right here. So, as it turns out, this is really, really ancient stuff. So, right, what I have here, I had to really take a strong gander at this little hole in the ground, and it actually turned out to be a low-angle impact site. So, I'm currently working on that. I've got all of the marks I need. I have the blast ring number 1 marked, and eventually I'm going to go ahead and figure out how the oval fits in there. And when I match the oval up, then I'm going to go ahead and be able to do a PowerPoint on that particular impactor. But this was a very ancient impactor. It happened eons ago. And after it had occurred, much of its greatest blast ring comes out into this region here. And when it had occurred, it basically just kind of like let the Earth loose. Now, if you look at the planet, if we consider that this was the North Pole then as this impactor struck at this location here, the material would have been flowing toward the south. And that is the type of signature that we look for. If the North Pole were here at the time this impactor had struck, this material would not have traveled toward the North Pole. Period. Not possible. It's not going to go up. It's going to go down. Down is the least resistance. So, if the impactor had struck when the planet was in the orientation of Pangaea's North Pole here, then that would be quite logical for it to flow in that direction, as it has appeared to come to here. And you've got basically it to some extent had created its own asthenospheric tsunami, if you will, that comes out. You can see it from this point here. You can see how that little change in the surface of the Earth comes out like this and flows around, and then from here it comes out and comes over here, and I'm not really sure how this happened. I think this would have at some point gone this way, and then later on with different things taking place around the planet, this had separated more out toward this direction here, where the ocean came in and washed it out. Who knows exactly every single detail, but I can look at the major details, and this is the theory I have. So that being said, that, as far as I'm concerned, proves to me that this was, in fact, the North Pole at some point in time, and so it's not just the spiral density fracture we have here in the Caspian, but we also have Norway out here and Finland, where filling up this terrain out here that is quite obviously from here. And that's not a volcano, folks. That's something else, right? Well, of course, because it has a footprint. I really had to struggle to look for it, but I did find one, and it's faint. And the reason it's so faint, now in this instance, the mainstream scientists are correct. It is very difficult to see some of the older things that have happened on the Earth because of weathering and that type of stuff. And this wasn't exactly one of your hugest impactors, right? And it was a very limited area that it had affected, even in the terms of possibly generating asthenospheric tsunamis to create this ridge out here. So that's pretty much what we're looking at right there, and that gives me my orientation for this. Now I'm going to go over, before I lose time here, you see on the left over here in my little panel I have Pangaean equator. So I'm going to rip down to the Pangaean equator. Now on Earth's normal current equator, you see the spiral density fracture coming out of Lake Victoria. It goes around this way, indicating that Lake Victoria is rotating clockwise. Okay, it rotates in the opposite direction of the spiral, of course, because if I were to spin to my right, being in a clockwise manner, if I were looking at myself from above, then the rope I would be holding is going to wrap around to my left as I'm turning to the right. This is how this works. Okay, so you see how very prevalent that spiral density fracture is, right? And then you come over here to Sapaliwini and you have a very prevalent spiral density fracture that indicates the direction of the vortex rotating counterclockwise. So this is the type of signature I'm looking for to help me establish my own confidence that the Caspian Sea at this very shoreline point would have been the North Pole. And it just so happens that it comes to about right here. So if you look at this point right here where you have the Dominican Islands, and I know what I've said. I said that the Dominican Islands were created quite likely from an asthenospheric tsunami that might have been generated by the impactor that struck in Hawaii, right here between Oahu and Hawaii. And if that's the case, in fact, I mean, you can from this point here see the P2W, right? So right here, that little blue dot, that's the pop. That's the point of penetration for this particular impactor, and it's sprayed out, and then you can barely see the little tip coming out here. Ladies and gentlemen, that's a footprint, okay? These islands were created by an impactor. So when this impactor struck, and that's where you get all these radial whip shock veins emitting out from it, mostly toward this the northeast, because of the direction of that. You see, it's in the same direction as that pop's pointing. Okay, so anyhow, if we look at the Pangaean equator, we're looking for the same kinds of signatures at about the same size for that you see with Sapaliwini, and the Dominican Islands in this ridge line here create that appearance. And so if this side of the if this, say for instance, was one of the primary vortices during the time of Pangaea, then on the opposite side of the planet, above the Pangaean equator, there should be a similar vortical signature. And when I do come to it, and if I do it right, it comes to about right here. So it right and it's alarming to see that it comes that way, and it's above. Well, we're looking at it below, but that's because this is the northern hemisphere of Pangaea, so to speak, right? So what we're going to have here is now you have this vortex or vortical core above at approximately the same degree as the Dominican Island vortex is below the theoretical Pangaean equator. That's strong. So now we have Norway. We have two vortices creating one vortical rod for the period of the Pangaean North Pole, and Now, there's a lot of things that have happened recently, i.e., the South China Sea impactor that created this horrible, huge vortex here, and basically created in Indonesia. Now, Indonesia might have already had some islands of some sort down in that area to begin with, and this just kind of like really ripped them up and moved them around and stirred them up a bit. Or it just totally created what might have been ocean at one point and made a lot of continental mass migrate down that way like liquid, kind of like slip. Slip's the best description. If you take slip and you pour it on top of a, what's it called? Stoneware? No, not stoneware. Stoneware is the clay. Greenware. Pour it on top of greenware. Watch the way slip behaves on top of greenware, and that's basically what you're going to get right here, right? Only give it a spin. So put it on a spinning table and watch it do what it does. Okay. Now, this is helping me suggest that there's a very strong likelihood that I am correct in that the North Pole of Pangaea was right here. And because we have an impactor on the body of Pangaea that has a tsunami that went toward the South Pole from Pangaea, that tells me that there's a good chance, and the reason that there's a good chance, not only that, but because of these vortical cores right here, Pangaea hasn't moved. So the North Pole of Pangaea has not migrated. So the continent that Pangaea is affixed to did not, or that the Pangaea North Pole is affixed to, did not migrate from the crack up here. Well, okay, then how did the crack get over here from over here, that kind of thing? Well, it's simple. So the crack is here, and it's going bloop, bloop, and it's spewing stuff out both sides. So at the same time it's spewing over here on this side, we have America for you, and over here on this side, well, it'd be more like this. And over here on this side, we have, Pangaea. So as it's spewing out, it's pushing, the crack is pushing itself away from Pangaea and pushing America away from Pangaea. So the crack itself is migrating, okay, from the Pangaean continent, the original continent of our planet for the North Pole. Okay. Good stuff. Now, India came into its shape during the current North Pole orientation. And that means that at some point the current vortices were relatively strongly active, and the entire continental virga type formations like clouds and rain coming down toward the South Pole probably happened very early on. And the reason I say that is because Guacanayabo here with this big B2W had hit the planet before the Yucatan Peninsula came into existence, and and it also has a blast ring that I can see up here through Mexico, which tells me that particular side of Mexico was there when this impactor struck. Not necessarily the mountains, but that particular land. And the mountains were later created by huge asthenospheric tsunamis coming down from the North Pole, which more than likely were affected at the same time that the South China Sea impactor created this vortical business here. So that's what we're looking at. I did the Pangaean Jupiterian stripes. So basically that's where I'm coming up with the theory that the planet has decelerated since the beginning of Pangaea, or at least the time that Pangaea had an impactor. And who knows, I don't know if I will ever find my fourth impactor. Right now it's a theoretical impactor. I have 3 confirmed impactors. My 3 huge confirmed impactors are 1, the South China Sea, 2, the North, this one right here, the North Pacific Oceanic impactor, and then the Gucanayabo impactor right here in the Caribbean. Those are the two or three monsters, and I was expecting that I would find another monster somewhere. I haven't found it yet. That might be one of those things where that could have been erased or something, depending on whether or not, you know, molten lava waves like this one came down and covered it, like if it was over here somewhere and it just went I mean, if it does that, then just like pouring slip, if you poke a hole in your, or dig a hole in your greenware, and you say that that's where an impactor struck, and then you pour slip on top of it and the slip goes down and fills that hole, then okay, well, unless you have the ability to dig the slip away, you're never going to find that hole, right? Okay, so that could be something that happened. There are instances where we could lose data, maybe not necessarily the effects from that blast, but at least the blast itself at some point, right? And now, so that's 2 vortices. We have to find 2 more for this particular zone, and I did work on them. I already plotted them. But these are the things that I'm looking at when I'm talking about Pangaea. And I thought this was interesting, so I wanted to make this video. And I am now out of time. So it was nice talking to you. Be sure to like the videos and let's see, subscribe. All right. I'll see you later then.